Today we're going to look at taking the antiderivative of e to the u. So the rule is not complicated. It's simply e to the u du is e to the u plus c. So again, the hardest thing to figure out is what is u and hope for the best with du. So I'm going to work through a couple problems with you, and then you should be able to do some on your own. Again, please hit stop, play, rewind, and see how I identify u and du. So in problem number 1, I have e to the 3x. So I only have a rule of e to the u. So if you have a e to the u in an antiderivative, that's about the only rule you can use. So e to the u, I'm going to choose u to be 3x. What is du? Du is the derivative of 3x, is 3 dx. So like we've been doing, if I need a 3x for my du, I'm going to 1/3 on the outside. So this becomes a 1/3 e to the u du. And what's the integral of that? E to the u. And then you put your plus c. In problem number 2, we have e to some power, so u is that power, and we hope that du is going to be involved again. So we need a -2, we counterbalance that with a -1/2, so you're really looking at -1/2 e to the u du, and the rule for e to the u is what? E to the u, so e to the 1 minus 2x plus c. And you can do a mental check again. The derivative of e to the u is e to the u times the derivative of u, which is a -2, and a -2 times a -1/2 is a +1, and you're with what we started with. So keep in mind when we have an antiderivative that looks like a product, remember we don't have a product rule. So we're going to try to fit this into a e to the u du, because that's all the rule that I have. So u in this case is going to be the power. Du is the derivative of that power. And again, I need 2x dx. I have 1x dx. So the counterbalance is going to be a 2. If we put a 2 on the inside, good mathematics tells us we have to put a 1/2 on the outside. And now just take your rule. So the integral of a e to the u is e to the u plus c. So basically, what you want to try to do is treat u as the power and hope that du is what we have left. So we have a du, we need a 9, we'll 1/9 it, 1/9 e to the u plus c. And again, where did that 9x squared dx go? It really is part of the du. 5, very similar. We have u is 2x square root of x. That's the power. And again, I don't know if you recognize this, but this is x to what power? This is 1 and this is 1/2. So this would be to the 3/2 power. The derivative of that is bring down the power. 3/2 times 2x to the 1 less power. So we have a 3x to 1/2 dx. Oh, it looks like we almost have that. We need a 3 on the inside, so we'll 1/3 on the outside. 1/3 e to the u plus c. 6, we have 2 e to the u's. So what you'll have to recognize here is u is not going to be 2x, but u is actually going to be the bottom. So I'm going to try to fit this into a du over u. How did I know to do that? Well, I have something on the bottom to the first power, so I know that might be my u du rule. The derivative of 1 is 0. The derivative of e to the 2x is e to the 2x times the derivative of 2x, which is 2, and dx it. So it doesn't really look like it, but this is going to become my du if I put a 2 here and a 1/2 on the outside. So now I have a rule for a du over u. What is the rule for a du over u? It's the ln. So I have a 1/2 ln of u, which is a 1 plus e to the 2x plus c. And the eyeball check of this is, let's take the derivative. So the derivative of an ln of x is ln of something. We put that something on the bottom. So that's where the 1 plus e to the 2x becomes on the bottom. We take the derivative of that, which is a 2e to the 2x. That goes on the top. And you multiply it by a 1/2. And again, we're back to where we started. So keep in mind, we don't have a product rule for antiderivating. So when we see something times something, that's not the rule. Somehow we're going to try to fit this into a u to the e to the u du. Identifying u will be sine of x. The derivative of sine of x is cosine of x dx. And this piece becomes our du. So we have everything we need. E to the u. The antiderivative of e to the u is e to the u plus c. Again, the check of this would be the derivative of this is e to the u times the derivative of u, and that's how we pick up the cosine. In number 8, when we have something to a power, we could treat this to a power and make it to the third power all over 3 if we had du. But what is the derivative of u? E to the x plus e to the negative x, and I don't have that. So on this problem, we're actually stuck with having to multiply this out before we integrate. So e to the x times e to the x, we add the exponents, we'll get e to the 2x. One of these and another one of these will be 2 of those. And what is e to the negative x times e to the x? We add the powers, we'll actually get 0. So we'll get just a 2 plus e to the negative x times e to the negative x. Add the powers, we'll get a negative 2x. Okay. And now we can integrate each piece. So e to the 2x, this is a e to the u, so we integrate that. We get an e to the u, but the counterbalance of this, we need a 2 on the inside, so we'll have to 1/2 on the outside. The integral of 2 e to the 0 is 1, so we're just taking the antiderivative of 2, which is 2x. Here, if I integrate e to the negative 2x, u is negative 2x, du is a negative 2, so I need a negative 1/2 on the outside. And we're antiderivative, so we put a plus c. The problems on the back are review problems, so what I'd like you to do is to pause the tape, do 1, 2, 3, 4 on the back, and 7 and 8. Omit 6, 5, and 6 because we haven't done those yet. So pause the tape, try those, and then I will replay with final answers. Okay, I'm not sure how long that took you. It took me about 5 minutes to work through those 6 problems. Let me highlight final answers. Here I just separated and integrated both pieces. In number 2, u should be sine of 5x, so the cosine acts as your dx, but du, so you have to counterbalance it. So final answer is sine to the 5th 5x over 25 plus c. And number 3, remember to separate, and then when you integrate each piece, This is your final answer. Number 4, you must multiply out first. So when I multiply out, I got x times x was x squared. X times 1 over 2x is a 1/2. And another negative 1/2 gave me a negative 1. And then negative times a negative is a positive 1 over 4x squared. And then I antiderivative each one of those separately. Number 7 and 7, I had to go to my book and look at the rule for tangent of u. There is a rule for the antiderivative of the tangent of u. It's the ln of the cosine of u. But again, u is x over 3, so I had to make du a 1/3. So I needed to put a 1/3 on the inside, which means I counterbalanced it with the 3 on the outside. And number 8, I'm going to try to make this a u to the 9th du. So I have a power. Du is 2, so I needed to counterbalance it with a 1/2. This gave me something to the power du. So I take it to the 1 more power, all divided by that power. And then I substitute in. When I substitute in a 1, I get 1/20 times 1 to the 10th. Minus 1/20, if I stick in a 0, I get a negative 1 to the 10th, which is a positive. So 1/20 plus another 1/20 is 2/20 or 1/10. So if you had any questions with those, please ask. Your problems are on page 358, 85 through 106 are all the integrating problems.